And we are live. Good evening, everyone. Welcome to a live chat for May 4th, 2022. And I'm not going to say the normal May 4th thing because I'm a Star Trek fan. So there we go. We had a little bit of echoes. There we go. All right. We're starting off really good. All right. So we have a couple things we're going to be talking about for today. There's a rainstorm on the way. We'll talk about that. I want to also go over some of the features that we are looking at for the summer forecast and the tropical forecast. I think you know it. Starts with an L, ends with a Nina. Looks pretty impressive. We're going to talk about that and what I'm looking at right now via various lifting parameters. And we'll take your questions and we'll see where it goes. As always, premium live chat. You get the questions there first and foremost. We answer all those. And then the best questions on YouTube, we go with that. In case you're wondering, I'll just get this out of the way. If you are going to ask about whether or not you can have plans for Friday night through Saturday, the answer is have an umbrella handy. You're going to need it. Or maybe some rain gear because it's not exactly going to be the best weather conditions. Mother's Day, Sunday, I'm getting a lot of questions about that. That looks a little bit better. We'll talk about that and the primary factors influencing the weather pattern and why I amped up some of the rainfall for this weekend, especially for Saturday, based on what I'm seeing. So let's pull up some data. You know the story. We'll walk through everything and we'll walk through, first of all, what's going on in the atmosphere overall. Now, for the past couple of weeks, I've been talking about this La Nina. And the reason why is that in the warm season, especially in the summer, the primary factors to influence the weather pattern comes out of your El Nino Southern Oscillation. Okay? So that's this right here. And when you have a moderate La Nina like this, coupled with a negative PDO, it really starts to enhance the polar jet stream and sets up an environment where the subtropical jet stream is basically being weakened significantly and the polar jet stream is being enhanced. And this leads to a couple of features. One, upper level lows. We've been talking about this for the past couple of weeks. See that influence once again. Today I'm going to show you some of the wind maps here on how that evolution is taking place, the physics behind it. Two, it causes the potential for sustained ridges, like a ridge around the Western Atlantic, so to speak, okay, or one around the southeastern United States that we're going to be talking about quite a bit over the next couple of months. And then there is the tropical hurricane season, obviously hurricane season in the Atlantic Ocean. Okay, why does La Nina have such an impact? Again, it revolves around the subtropical jet stream, not necessarily impacting sea surface temperatures or instability in the atmosphere, but the ability to reduce shear. So let's take a look at the upper level winds. And you could see La Nina's influence clearly already. This is our subtropical jet stream. Now, during El Nino years, this subtropical jet stream is amplified, which leads to pretty significant severe thunderstorm outbreaks over the southern plains, especially around central and southern Texas and the Gulf Coast, because you get these strong disturbances marching across the Gulf Coast. And it also leads to a strong jet streak over the Atlantic, which shears apart tropical systems like a buzzsaw. So that's why when you have a moderate or strong La Nina during the summer, you barely get any tropical systems because every tropical low that tries to form basically gets decapitated before it has a chance to become anything significant. Every so often you do get a strong storm, but even then you have more of a potential for a disruption of the circulation because warm core lows, unlike cold core lows, have to be vertically stacked. So if you have a portion, especially the upper portion, kind of displaced like this, then the engine doesn't work properly and you don't have the proper mechanisms to maximize your evaporational cooling and latent heat release factors, and basically your thunderstorms, what you see on your satellite pictures, that your thunderstorms get blown off to the east or basically displaced from the center. In La Nina, exact opposite. In La Nina, our subtropical jet stream is much weaker. Our polar jet stream, which you can see right here, is significantly amplified. You get more upper level lows. Why? Because you have so much spin going on in the atmosphere here that you can get these little cut-off lows that just constantly repeat itself and enhance itself. So you got your polar jet stream here, and then every so often, part of the base of these polar jet streams, with short waves marching their way through, starts to break off. And that's how you get your upper level lows. Now, your upper level lows are further enhanced by other upper level lows in other areas of high latitude blocking off to the east, like what we're seeing here in the Atlantic, which we've been seeing constantly. Notice in the Atlantic, you have your upper level low and upper level troughs forming, your polar jet stream very much amplified here, but your subtropical jet stream, well, not all that impressive at all. It's pretty weak. So if you get a tropical wave able to march its way across the Atlantic here, it's not going to run into much in the way of interference, at least from upper level winds. So this is why the tropical Atlantic season tends to be more active during La Nina years, because you have less potential for hindrance. You have less potential for any of these disturbances to become decapitated, and they'll be capable of maturing. Now, not all of them become hurricanes, but you get a number of tropical storms, subtropical storms. Other thing to watch too this year is subtropical storms, especially if you get a little shortwave splitting off of this trough here, trying to drop south. And the way that they're naming the subtropical storms now, I would not be surprised if you see 5 to 10 of these subtropical storms this year on top of the tropical systems that we're going to see this year. That's primarily going to be focused around old cold front boundaries, possibly running into a southeast ridge or a western Atlantic ridge. So that is your tropical forcing, but there is more. How about, if I could pull up the right map here, here we are. Okay, let me go back here first. Remember what I said, the sun is active, very, very active. I had a chat earlier on this week about the idea of a grand solar minimum, that the sun is not as active. Let me tell you something, guys. The sun is way active, and it is more active than what was actually forecasted, way ahead the scale. So the amount of sunspots that we're seeing, the intensity of the sunspots we're seeing are ahead of the forecast. They're very impressive. And what that's doing is that's interacting with all this ozone left over. Now, over the past couple of weeks, we've seen a steady decline in the ozone in the atmosphere. Okay, ozone is really focused in the stratosphere and ionosphere. But in the stratosphere, it's important to keep track of the ozone because of the ability for it to cool or warm the atmosphere. A buildup of ozone leads to a warming of the atmosphere because you're increasing the mass within a known stated area. So the stratosphere is able to expand just a little bit, okay, and that presses down on the troposphere, where we are, and that leads to a lot more below normal heights. When the stratosphere is cooling, it contracts. Okay, because the ozone's being destroyed from the increased solar activity. So the increased solar activity breaks up the ozone, causes a weakening, and when we started out a couple of weeks ago, we were here. Now we're down to around here. So a steady weakening, steady depletion of the ozone, which is typical for this time of year, but it started off at such a high point, it has a lot of work to get through. So as a result, what we've been seeing is a steady cooling of the stratospheric environment. We were pretty warm. Now we're getting pretty chilly up there. Notice where we are seeing cooling and warming. We're seeing warming around the equator. Okay, we're seeing a little bit more transport from our EPV flux here. We're seeing cooling at the mid-levels. Keep an eye on this area for very strong ridges. And also with the cold environment here in the stratosphere and then the lower troposphere, it leads to a greater potential for instability. Why? Well, let's say, let me pull up a little. Okay, so this is a parcel of water vapor, right? When the atmosphere is overall warm, okay, the parcel can only rise so much, okay, because the environment around it is pretty much just as warm as the parcel itself. When you have a cold environment, this parcel, this water vapor, can shoot up into the atmosphere. And when it shoots up into the atmosphere, what happens is that it allows for more explosive development of convection, thunderstorms. This factor is not only important for when we're dealing with severe weather this year. You've already seen it in the plains. You're seeing it right now. In fact, in Oklahoma, with some dynamic thunderstorms and some tornadoes. But it also increases the potential for rapid intensification of tropical low pressure systems. Like perhaps maybe a tropical storm intensifying rapidly into a Cat 2 hurricane, something of that nature. Why is that the case? Because the cold environment is enhancing the latent heat release process. It's allowing the thunderstorms to grow higher up in the atmosphere and push into higher levels of intensity and lift. And that leads to more intense thunderstorms, which means a better potential for more rapid intensification of warm core low pressure systems. And we're seeing that right around where we would pick up the tropical Atlantic. So keep an eye on this theme. Also notice we have some warm pockets here around the Gulf of Alaska, around Japan, and around the Northern Atlantic. We have to keep an eye on this because these warm pockets leads to below normal heights. Now we have below normal heights around the Aleutian Islands, around the Gulf of Alaska. Then that supports the potential for below normal heights and troughs around the plains and the Tennessee River Valley. That also supports below normal heights around the Northern Atlantic, i.e. negative NAO. And I know everyone's going to say, the negative NAO, where were you all winter? Now you're here in the summer and in the spring. I get it. I understand. I don't control these things. It is what it is. Different wavelengths sometimes leads to different configurations and thus different patterns. In this case, you get your negative NAO set up and you have the forcing mechanisms available at the sea surface temperatures and at the stratospheric level to enhance this potential. Not necessarily driven by a negative Arctic oscillation or anything, because the polar vortex is dead, gone, not even an issue anymore. But this environment plays off each other because now you have below normal heights here around the Canadian Maritimes and Northwestern Atlantic, which enhances the potential for a Western Atlantic ridge, which enhances a favorable environment over the tropical Atlantic into the Gulf of Mexico and up the East Coast. And also it enhances the potential for short waves in the plains to cut off into upper level lows and march their way towards the mid-Atlantic. See how everything all plays in? Start from the stratosphere, go down to the sea surface temperatures, everything's connected. Okay, so never look at the atmosphere with just one factor or one feature. You always want to look at everything combined, kind of like a 4D chess, okay? Because one feature interacts in place with the other. And every time they interact, you're going to end up with a slightly different solution. So you can't always go with what happened in other years, but you can kind of make a guesstimate based on the way that the atmosphere is playing off against each other, which is why observations are so much more important than just whatever model output you're looking at. You want to use the models as a tool, but you want to compare it to the actual observations and what's happening and be able to adjust. Never lock yourself into a forecast if the observations change. Not so much the model data, but if the observations change, then you have a different base state that you're working with, which then leads to and opens up different potential outcomes. So that's what we're studying right now. So now we understand the full atmosphere, and we'll go over this again and again. We'll have the summer forecast and the tropical season forecast out this month. I'm working on it now. I got my notes done. I'm kind of walking through everything, adding in more details than what we went over here. But a lot of interesting stuff to really keep an eye on. That takes us to our storm. And our next storm, let me refresh this, is getting its act together right down here over the plains. And as I was discussing earlier, it is producing some rather impressive thunderstorms out in my own stopping grounds. When I was just got out of college, I was living out in Oklahoma, right around Oklahoma City and Edmond. And off to the east of there, some very impressive thunderstorms. We got a tornado warning issued out here. We have a dry line marching through, warm front lifting north, just a real mess. And this low pressure system will be visiting our neck of the woods by the time we get to Friday night. Now, notice in our weather pattern here, we have our polar jet stream kind of riding to the north and kind of a separate branch of the polar jet stream, kind of a split branch here, with this feature right here starting to cut off and become a pure upper level low that's going to pinwheel its way through the region. Meanwhile, our subtropical jet stream is pretty weak, but you can see the development here of a ridge starting to form out here. So you can see this setup here, this pattern, but all of this is all driven by this upper level low that's about to dive south and block this whole pattern up like as if it's traffic on the LIE. And you can see that pretty nicely here on the water vapor satellite picture. Here's this morning's rainfall exiting out. One thing that I am keeping an eye on, and let me go, not necessarily for this storm, but just something that I'm kind of keeping an eye on for themes in the pattern, is I'm constantly seeing convection kind of bubbling up to the north of the Bahamas. This is not tropical in origin, and this storm coming up has no warm core components. I want to make that very clear. This is a pure cold core system. But it is interesting that we are constantly seeing convection firing up to the north of the Bahamas. And as we move towards the tropical season, that's a theme that we're going to have to watch very carefully. So just keep that in the back of your mind. Here's our storm out here. And again, with our environment in the stratosphere and the lower troposphere, look at these thunderstorms fire. Very impressive cold cloud tops. Everything's all starting to evolve and set up. So, on our 500 millibar pattern, we've been watching this for the past couple of days. And in the severe threat analysis and in various videos, we've been talking about this rainfall on the way for this weekend. I recently enhanced the rainfall over the past 24 hours of doing the forecast based on what I'm seeing with the evolution of this upper level low. So at 500 millibars, we see this upper level low approaching from the Ohio River Valley. We have nice divergence and diffluence at 500 millibars right here. So you got the support for lifting. That really hasn't changed all that much. Same thing at 700 millibars and 850 millibars. But what has allowed me to amplify the rainfall potential is what we're seeing here with our low-level jet. This jet streak here is a calling card for just a fire hose, once again, of moderate to heavy rainfall right into the Jersey shore. Now, it marches from southern New Jersey up towards the New York City Metro and then lingers right around the New York City Metro and Long Island into northeastern Pennsylvania, starting Saturday afternoon and continue on into early Sunday morning. This type of environment sets up the potential for about 1 to 2 inches of rain because it drives up the precipitable water values, but also enhances the potential for some of these winds to get mixed down to the surface. So when you see this type of jet stream, because of the significant transport of moisture coming right out of the Atlantic, and part of this is coming from the tropical Atlantic, so you're enhancing your precipitable water values with this transport, but you're also enhancing stretching of the atmosphere and a frontogenical environment where you could set up bands of heavy rainfall just rotating on in on Saturday morning and Saturday afternoon. So very, very interesting scenario setting up with this rainfall. And so when we're taking a look at the next 90 hours, again, for this evening on through tomorrow, pretty quiet out there. Here comes our rainfall coming in Friday evening. I've been getting questions about baseball games and whatnot on Friday evening. It does not look good. I'm pretty sure MLB will try to play these games, but they might not exactly be very pleasant outside to do so. But the steady heavy rain should hold off until after about 10 p.m. So that's something to consider. But I would not be surprised if they're playing through rain on Friday. And then Saturday is just, well, it's just a mess most of the day. And not only are you going to have heavy rain, but again, you're also going to have strong easterly winds. It's a raw day, temperatures in the lower to mid 50s, winds coming in from the east around 10 to 20 miles per hour away from the coast, 15 to 25 miles per hour along the coast. And those of you along the coast, do not be surprised if you end up with some coastal flooding. That's going to be an issue as well because of this persistent east wind. That's not going to allow the water to exit out. And in general, we're looking at 1 to 2 inches of rain out of this. Now, let me just pull up one other thing here. Pull up the 500 millibar heights after this storm. So look at this environment that sets up for next week. The key to next week, and why I'm not jumping on the latest guidance just yet, is how this ridge and this upper level low will interact, because these two are going to play off of each other. So depending on the orientation of this ridge and this upper level low, it could either transport just enough moisture to keep pesky showers in play for most of next week, or this ridge is able to push just enough further south. Let's say that this ridge axis sets up around central New Jersey rather than Long Island, then that would transport most of your showers down towards the southern mid-Atlantic, and it would also enhance sinking air over us, making for very pleasant conditions for the entire week. The ensembles like the more pleasant idea better than the operational, which keeps showers in place. So just something just to keep it in the back of your mind. But I mean, look at this pattern. If not for this upper level low, you would end up with this broad ridge. A nice trough over the west, very pleasant conditions, probably a nice warm up, temperatures in the 70s and 80s. But because of this upper level low, which is able to form because of the active nature of the polar jet stream, allowing these short waves to break off and form into upper level lows, the upper level low plays off and enhances the ridge because there has to be a balance in the pressure and in the height fields. So you get this ridge axis that intensifies in relation to the upper level low, and they play off each other until one of each collapses, and then you start to see this kind of negatively tilted trough become gradually absorbed into this larger trough out here in the west. So very interesting pattern all setting up. And look where our below normal heights are all located in. Remember where I started? Back when I was talking about the below normal heights over the Aleutians and Gulf of Alaska, and then over the northern Atlantic. That's where we have our impressive upper level lows. So you see, everything is connected. So now we've gone over all that. I'm going to take some of your questions. Again, I'll first do the live chat here, and then I'll go to the YouTube chat and pick up the best questions you got over there. So let's see what we got. Okay. The impact of this weekend storm really ramped up. Yes, it did, because of the realization of the subtropical, of the low-level jet stream. Looking at Earth News School, easy to see how the weak subtropical tropical jet is at this point, while the polar jet stream is really amplified. Typical La Nina, absolutely. Would the convection north of the Bahamas, if it stays persistent into the summer, impact the location of the Atlantic ridge that La Nina promotes? Excellent question. I think that the convection develops around and under the upper level ridge. So what that means is that the reason why I'm focused on that convection is that what happens is that at the lower levels you can get these warm core low pressure systems that develop, and then in the upper levels you need the higher pressure to evacuate out the latent heat in the water vapor release. So what you typically are looking for is this transport of heat with the convection, and then a ridge axis over it that allows for the warm core low itself to basically mature. Warm core lows typically are not very high in the atmosphere. Okay, most warm core lows really are at their strongest at the 850 millibar level on down to the surface. That's where you really see a lot of the action, a lot of the intensity and energy release. And you need that anticyclonic circulation, i.e., high pressure, at the higher levels, 500 millibars and above, to allow for the exhaust, so to speak. So I think that it has the potential of enhancing the ridge, especially from the Bahamas to the eastern Gulf Coast, which could be a problem for those in the central and western Gulf of Mexico, and also for the East Coast. So something just to keep in the back of your mind. Do you think there will be more homegrown thunderstorms once the tropics become active? I would guess you mean by like cold fronts and waves of low pressure developing off of old cold fronts. I could definitely see that being a theme. I definitely can. If the conditions are right, yeah, I could definitely see that being an issue. What do you expect weather-wise for Friday and Saturday at Churchill Downs, Kentucky? Oh, right. They're doing horses or something, right? Well, let's see here. We usually forecast for Kentucky, but well, I mean, it looks like the bulk of the rainfall. When is this thing? Friday and Saturday? Horses? I don't know. Oh yeah, I think so. I don't know. I don't follow it either. Um, let's see here. I kind of consider horse racing like car driving. It's like the jockey didn't. I don't know why the jockey gets all the rewards and stuff. He didn't do anything. He just sat in the horse. The horse did all the work. I think the horse. I think the horse should get like premium food, and like it should be like all the horses. They get the best food, and they get the money. You know, I don't think the jockey. Forget the jockey. Leave the jockey out of it. Who cares? It looks wet. Yeah, it definitely looks like there's showers and whatnot. Not the best conditions. I would say postpone it to Sunday. You'll be able to. Can they do that? I don't know. But it looks like it would be what I guess it'd be wet out. So the horses should wear ponchos so they'll stay dry and comfortable. And I don't know if they do that. I have no idea. But it's going to be wet. So definitely that is for sure. Much more looking at the long range. New York, North Carolina, New Jersey looking big time tropical trouble come August, September. Maybe. In La Nina years, keep an eye on two things: a negatively tilted trough in the Tennessee River Valley and a strong Western Atlantic ridge. If you see those two factors constantly show up this summer, then we're really going to have to keep an eye on things. If you just have a general Western Atlantic ridge and you get a trough, let's say, around the Mississippi River Valley, that typically leads to tropical systems ending up towards the Gulf of Mexico, or they stay out in the Western Atlantic. They don't typically impact our neck of the woods, because usually what happens is that cold fronts approach at just the right time to kind of kick the storms out of here like a goalie, you know. So that's where I would watch out for in terms of tropical concerns. What's the timing of the rain and wind on Friday and Saturday? Looks like steady rain after 8 o'clock for the region, and the winds really ramp up Friday night, like after 11, on through Saturday morning, and probably start to taper off by Saturday afternoon as the structure starts to drop south. But Saturday is all rain. Saturday is just a mess with waves of rainfall rotating in from the Atlantic. Friday, most of the day will be dry, but the evening you'll feature rain. So if you have tickets to go to a Mets game, Phillies versus Mets, I know this weekend, and then I think the Yankees are home too. I have to check. But either way, not exactly the best conditions for outdoor activities, that is for sure. Rob Allen says, the Euro long range shows my fear exactly. Big ridge, southeast, upper level low. You can see the funnel direction. Ugly. Potentially, yes. Potentially, yes. You know, it also introduces the potential for above normal rainfall and the prospect for flooding from remnant tropical systems or just training thunderstorms with dying cold fronts. So definitely a concern, absolutely. Let's see. Unless it's an absolute downpour or there's lightning, they will run, which impacts those who bet because horses run better on sloppy tracks. I did not know that. I would think that they would run better on dry tracks. What do I know? I don't know. I can't run anyway, either way. Sloppy, wet, it doesn't matter. I cannot run very well. Okay, I'm not a runner. I'm more of a lifter. But I will say this. Those horses are going to have, if they like running in the rain, they're going to love this track then. So concern at this point for either near hit or very heavy rain from remnant storms like what I did last year. Yes, exactly like I did last year. Absolutely. Okay, let's take a look and see what's going on in YouTube land. Let's see here. Good evening from Cape May. Good evening. How you doing? Hurricanes on the East Coast, will they be more intense this year compared to our normal storms? That's a hard answer. See, here's the thing. Tropical systems are very fickle creatures, okay? They can ramp up and reach Category 5 and become devastating, but all you need is a little bit of dry air. Just a little bit, not much, just a little bit, just a little sliver working its way in at 700 millibars, maybe from a little short wave to the north of the storm, and it could derail the tropical system and weaken it. Or a slight interaction with landmass. Let's say it's passing to the north of Cuba, interacts with some higher terrain, introduces a little bit of disruption of circulation, and the low-level circulation starts to decouple. Little tiny factors can impact these storms. So I don't like to go around and say, well, this year's storms are going to be more intense. What I will say is that the environment is present for the potential for intense hurricanes. So it's a higher potential. Not a guarantee, just a higher potential. Where would the bulk of heavy rain affect New Jersey from this nor'easter? Okay, that's a good question. I'd say from Long Island down through New Jersey, your focus should be on the coast. And the reason why is because that's where your strongest jet streak is going to be. Let me zoom out here for a second here. Watch as this evolution takes place. So your focus is going to be right here, right along the Jersey Shore. Thanks for the chat. Thank you for joining. What are the factors to get a hurricane from New Jersey? Every environment, every forecast is different. But generally, for a tropical system, what you would look for is a negatively tilted trough in let's say the Tennessee River Valley, which is right here. So you get a trough here. You have a Western Atlantic ridge here. And so that funnels storms up the Jersey Shore, typically. Now, I know everyone's going to try and compare every system to Sandy. Let me be very clear about Sandy. Sandy was a freak of nature. Not so much the strength, but the way that the storm formed and the way that several features came together just right to slingshot the core of the storm perpendicular into the Jersey Shore. And that's really important. Most of our tropical systems run parallel. So what happens is that on the north side, you get all of the rain and winds hitting the coast, but then the south side has everything driving out. So what happens is that the initial storm surge coming in is able to evacuate out. Okay, you still get damage, but it gets to evacuate out. In Sandy, it came in like a punch. And it didn't allow the waves and the water coming into the coast to exit. It kept on driving everything in. And so there was no respite. And you had the worst conditions slam right into Ocean and Monmouth County and right into Long Island, the South Shore of Long Island especially. And there was no way for the water to exit out until the storm was well gone. So it was a very rare and dangerous situation, but it's not something that is likely to be repeated. Okay, back to the chat here. So, concern at this point for either near hit or very heavy rain for remnant storms like, oh, okay, I already read that question. There we go, more down here. It would help if I scrolled. That would probably be a smart thing. Let's see. What are your thoughts about MCS derecho systems? If so, do you see further advancement to the coast than normal? That is going to have to be a case-by-case scenario and study. If we end up with kind of like a ring of fire scenario, and let me explain what that means, okay? Ring of fire is when you get this ridge here built into the coast and you get short waves rotating around the ridge, lifting up towards the Great Lakes and dropping south through the mid-Atlantic. Now it becomes a little bit more possible because you get these upper level troughs and upper level lows setting up around the Canadian Maritimes where you can set up some polar air masses and short waves diving south. So that could potentially enhance the potential for MCS this late spring and summer, but I wouldn't guarantee it because they can be awfully fickle. See, MCSs, they play off a lot on outflow boundaries, which are boundaries left over from old thunderstorms, kind of like the cooler air from the thunderstorms. So there's those factors. There's sea breeze front factors. There are mid-level factors as well to consider. So I don't want to make a declaration with so much volatility involved in such a forecast, but the potential is certainly there. Depends on the horse. Do they have Mr. Ed? Maybe he can psychologically mess with the other horses. That'd be cool. I think they did a movie on that. In the 80s or 90s, I'm not sure. The mountains of Hispaniola are known for disrupting tropical systems that pass over them. Everything in the Greater Antilles, which includes Cuba, Hispaniola, and Puerto Rico, these islands, and Jamaica too, these islands can create havoc with the development of tropical low pressure systems. And many storms have come barreling in very strong after interacting with these islands, never becoming as strong again because it disrupts the core structure of the storm. So yes, absolutely. The geography of these islands can cause a lot of issues. And that's why when you're taking a look at model guidance, and let's say that it's taking a tropical system into Florida, but first it's moving through Puerto Rico or the Dominican Republic, and it doesn't weaken it, that's an error, because you know that with that interaction of landmass, there should be some weakening. The only way you don't get weakening is that if this storm is like booking at 20 miles per hour and it just doesn't have time to be disrupted, maybe that could be a factor. But that's pretty rare. But these islands can have a major impact on the strength and the track. Because sometimes what happens is that interaction occurs and the warm core low decides to jump the island or shift south to remain out of that disruption. It basically tracks towards the area of least resistance. So then the forecast has to be adjusted further south or further north, depending on the factors that be, and that can completely change your forecast as a whole. So tropical low pressure system forecasting is always fun. It's always a challenge. Let's see here. It looks like we got some good questions tonight. Absolutely outstanding. While I'm waiting for more questions from you guys, let me go jump on and take a look at some of the observations here. Again, the Southern Plains looks like a real mess out here. Let's zoom in on some of these storms here. Impressive storms, to say the least. So this is a tornado warning. Tornado observed right about here. Nearly textbook. Look at that. You can see the tornado's likely right around here, marching its way through. Your core shaft is up here. If any of you guys ever go chasing, be very careful and stay away from anyone like a medical, like ambulance, ambulance or fire trucks or anything. Try not to get in the way of those guys and try to stay at a distance of these storms. That way you can watch in the distance but not get in the way of any type of emergency situation. That's like Hurricane Dorian. All the models originally south of Hispaniola, Puerto Rico, ended up going north. Yep. And the 12Z suite went from a tropical storm to a Cat 5, destructive across the board. Yeah, absolutely. I noticed that the extended SPC outlook shows some threat through day 6. So it looks like an active week of severe weather. Let me pull that up. Yeah, the planes definitely will remain active, that's for sure. Doesn't surprise me. A lot of activity. Like I was saying back with the spring forecast, the plains is going to see plenty of thunderstorm activity, and thus far is not disappointed. And unfortunately, we're going to be watching these dangerous tornadoes and thunderstorms break out. And when it comes to severe weather, whenever you're around this warm front, a lot of people assume that it's the cold fronts that create a lot of severe weather. They do not. It's actually the warm fronts. When you get these warm front structures over the southern plains, they, along with the dry line, can create significant, nasty thunderstorms that can produce long track tornadoes and impressive severe weather. Usually the cold front comes in almost like it's an afterthought. It's kind of like a cleanser to clean out the atmosphere. But the main event is usually right around the warm front. Which again we are seeing this evening. Very impressive thunderstorms breaking out. You see that all the way down south here, and you can see the outflow of these thunderstorms extend all the way out well northeast of the actual development. Pretty impressive storm to say the least. Let's see here. Check out any more questions. All right, it's 8:45 already. So we'll go about another 5-10 minutes unless we have any more questions, and then we'll call it a night, and then we'll get ready for the weekend. Which one? Will Saturday afternoon taper in gusts and winds? Oh, gusts and rains. um, Along the Jersey Shore, not until the evening hours, based on what I'm seeing right now. The further north you are, the faster you'll see a reduction in the rainfall. So if you're in Connecticut, you'll see a faster reduction by the afternoon. New York City Metro by the evening, southern New Jersey late Saturday night. So let's see if I can pull this up again. Pull this up. So as you can see, the rain comes in Friday evening, Friday night. Everyone's getting a heavy rainfall. And then as we go on through the day on Saturday, notice Connecticut, you're not as heavy as a rainfall. And then it starts to subside and drop south towards the evening hours. So the further north you are, the more likely you'll end up with improving conditions. The further south you are, you're going to have to wait till Sunday afternoon. When do you see our area having the severe and the potential for tornado threat get higher? Usually that's in the summer for us. I don't usually see that in the spring, especially when you're dealing with a lot of backdoor cold fronts, because backdoor cold fronts transport stable, moisture loaded, but stable atmospheres. So you're not likely to see a lot of severe weather events in those type of environments. But in the summer, especially, we can introduce tropical air masses in mid-June, July, and August. That's when we're likely to see thunderstorms. And I'd be wary of tornadic activity when we start to see the increase of precipitable water value on average for events pushing above 1.5 inches. And when we see more of a vertical wind shear, directional wind shear, setting up with some of these upper level lows. But first, we need to see that precipitable water values push up a little bit. So once we get to 1.5, we'll start to see more dynamic thunderstorms, intense heavy rainfall, the potential for mesoscale low pressure systems to develop in these thunderstorms, and that would introduce the potential for some tornadoes. I cannot say we'll end up with the same type of season that we had last year, because that was pretty interesting in terms of the evolution. Don't know whether we're going to end up with that same evolution. But one thing I'd be very interested to keep an eye on, watch out for the I-95 corridor. Watch out for this area and this area. Basically, the Delaware River Valley. Now, why am I highlighting this area? Because these areas are being enhanced by our urban heat island effect and how much we're building and how we're building. And that is enhancing the thermal gradient in these areas, interacting with the sea breeze fronts, which is enhancing low-level vertical wind shear, let's say from the surface up to about 925 millibars, which is why we're seeing more of these mesoscale low-pressure systems and the potential for these weak F0 and F1 tornadoes. Weak in terms of the scale, but still destructive nonetheless. So I'm going to be very interested to see if we get a repeat of that in the same areas that we've been seeing, or whether we see any type of shift. But this area here lines up perfectly with the urban heat island effect that we've been seeing and how that's been enhancing the thunderstorms because of the thermal gradients involved. So some very interesting stuff that I'm definitely going to be keeping an eye on. Let's see, got any more questions? Well, I think that's about it. Again, wonderful chat again tonight, guys. Excellent questions. If you have other questions or you want to talk about something that we didn't talk about tonight, definitely email me that way I can prepare for it, and we'll touch on the topic. In the meantime, I hope everyone who is celebrating have a happy Mother's Day out there for this Sunday. And also, just enjoy the weekend. Sure, it'll be raining, but it's a good weekend to catch up on some movies, stay indoors, play Monopoly, play Super Nintendo, whatever. But definitely just stay safe out there and use some caution. And we haven't had the ice cream truck showing up, so fingers crossed. At least not during the chat. So fingers crossed on that. Hopefully that remains the case. Have a wonderful evening, and as always, stay safe out there.